All right, today we're going to talk about the second type of symmetry that we got to talk about, which is rotational symmetry. First, I want to talk about mathematical symmetry in general, though. I meant to talk about this in a previous video, but it's important to note that there's a difference between mathematical symmetry and other forms of symmetry. Symmetry is a word used in writing, in art, in everyday speech, so layman's terms, philosophy, all this stuff, where we might say something is symmetrical or something exhibits symmetry, but it's not mathematical symmetry. So the distinction is important. If we take a look at this piece of art, many people, or everyone would probably say that this exhibits some symmetry. You've got one elephant on this side, you got one elephant on this side, there's the triangles, there's the people. But mathematically, there's no line of symmetry here, right? The trees don't, when you fold them over, there's no line of reflection. It's the elephants are slightly over to one side, the people aren't perfectly centered. So mathematically, there's no symmetry in this image. However, somebody could easily say this image is symmetrical, and they wouldn't be wrong. Okay, so it's important to note what kind of symmetry we're talking about. It's also important to note that in math examples, they might say, okay, how many lines of symmetry does this have? And technically, they might not be right because maybe there's, in a digital picture, maybe a pixel is off or something. But there has to be some margin of error that is allowed for. Okay. So let's get into rotational symmetry. A shape has rotational symmetry when it coincides with itself after a rotation of less than 360 degrees about its center. Kind of confusing, but what we mean is if we take the star and we're just putting a dot in that tine of the star so we can see which one it is, and we rotate it once, or we rotate it a little bit until it matches itself again, that dot will now be at the bottom point. And we're going to rotate it again until it matches itself. Okay, and it's at this point now. And we could do that. We would go 1, 2, 3, 4, 5 times. So we'd rotate it 360 degrees and it matches itself 5 times. So the number of times the shape coincides with itself, like we said, the star would be 5. The order of rotation is that number. So this star has an order of rotation of 5. And there's kind of this gray area that I found. It's kind of like when mathematicians are talking about zeros. Some things need a full rotation of 360 degrees before they match up. So they have a rotational order of 1, or an order of symmetry of 1. And some sources were telling me, oh, no, you can't have a rotational order of 1. And then others were like, yeah, you can. It just means it's not symmetrical in any way. Because everything has a rotational order of 1. So it's not super useful to say it has a rotational order of 1, or an order of rotation of 1. But what I'm going to go with, what I kind of have synthesized among the reports that I've read, is I would say it's possible to have an order of rotation of 1. It just means it doesn't have any symmetry. Like this little guy, if we flip him around, there's no point that he's going to line up until he's back to 0 degrees, right? So I would consider it to have an order of rotation of 1, but an order of rotation of 1 means that it doesn't have any rotational symmetry. So it's an important thing to note. This slide here is essentially the core concept that you need to know for rotational symmetry. You need to know how to identify order of rotation, and you need to know what rotational symmetry means. What will help is some of these examples. I think the easiest way to figure out if something has rotational symmetry is to just go into a computer and get a rotational tool going. Or maybe not the easiest way. This is probably the most accurate way. And you can just click on something on a little, which layer are we on here? This guy. So you can click on this thing and we can just rotate it. And we stop when it matches up. Oh, okay, it matches up right there. So we have rotated once. And we stop when it matches there. Okay, it's rotated twice. And now we're back to the original. So it's matched itself 3 times. So that means our order of rotation is 3 for the recycling symbol. The snowflake is maybe, well, it's not harder, but it has more orders of rotation. So every time this tine, we'll take this top right tine as our starting one. Every time it hits one of these, it's going to match. So it would go 1, 2, 3, 4, 5, 6 times. Order of rotation would be 6. It's important to be able to try and do this in your head because obviously you don't have, well, I suppose now you do that, it's online classes, but um, when you're doing a test or something in school, you wouldn't have a digital tool to help you figure out the order of rotation. So what we're trying to build here is a bit of a spatial sense of what has an order of rotation and what doesn't. This shape here, you should look at it for a second and realize that it actually can't match itself until it goes all the way around. Okay, so that would have an order of rotation of 1. Oh, let's cancel it. Same with an isosceles triangle. This will never match itself. You can spin it all the way around and it won't matter. So no rotational symmetry or order of 1. This is a neat one. It's got an order of 2. And it's also connected by a line of symmetry. So things can have both rotational symmetry and line of symmetry, right? The line of symmetry would be right through the center, the connecting point of those two squares. And then it would also match when we rotate it 180 degrees. Order 3 for an equilateral triangle because this point will end up hitting that point, which will end up hitting that point, and then back to normal. Equilateral crosses are very common for order 4. And you'll notice even-sided pentagons, hexagons, octagons, those will all just have an order that matches the number of sides they have, or the number of vertices they have, doesn't matter. So these are some examples of shapes with a ton of different orders. There are more complex things, like there's pieces of art that exhibit rotational symmetry, and those make it quite a bit harder to see. So I encourage you guys to go check out, maybe just search art rotational symmetry on Google and do an image search. And you might see some stuff that it's maybe a little harder to figure out what order it is. Okay, everybody, have a good rest of the day. Cheers.